Usually when you picture a home aquarium, the image that comes to mind is just, well, absolute tranquility.
Right, yeah. Like a little Zen garden.
Exactly. It's gentle, bubbling water. You've got maybe a glowing light casting shadows over some decorative gravel.
Right. And just fish kind of aimlessly drifting around.
Yeah, it's a space designed to basically lower your blood pressure. It is essentially the ultimate living room white noise machine.
It really is a highly curated aesthetic. I mean, we construct a fish tank and we completely expect it to deliver this uh, sense of peace, a tiny slice of serenity right in your house.
But the thing is, that piece is entirely an illusion.
Oh, totally.
When you actually zoom in and look closely at the dynamics inside that glass box,
Yeah.
especially if we were talking about a cichlid breeding tank, that tranquility just vanishes instantly.
Yeah, it is not a peaceful place.
No, we are definitely not looking at a screensaver here.
Yeah.
We are looking at a fiercely competitive, highly pressurized micro ecosystem. And survival there hinges on incredibly delicate timing.
It's basically a masterclass in behavioral ecology. I mean, the tank is an environment defined entirely by its artificial boundaries,
Right.
meaning every single biological imperative a fish has is magnified. There is literally nowhere else for them to go.
And today, for you listening, we are going to unpack the mechanics of that exact microecosystem. We're doing a deep dive into a really meticulous log kept by an aquatic breeder named Aang.
Yeah, it's a fascinating document.
It really is. Specifically, we are looking at an entry titled Notes on Fishkeeping, Part 287, and the subtitle is Optimal Timing for Separating Cichlid Fry.
And just to establish the baseline for everyone, fry is just the technical term for baby fish.
Right, baby fish. So our mission in this deep dive is to deconstruct this incredibly precise window of time a breeder has to, well, separate these fry from their parents.
Because it is a razor-thin balancing act.
Exactly. According to Eng's notes, this isn't just a simple matter of scooping babies into a new bowl when they look big enough. It is this intense balance between the physical limitations of the tank and the unstoppable, ancient biological drives of the fish.
Yeah, it's literally life or death based on the smallest things.
We're going to explore how something as seemingly mundane as, like, a flat rock or even just a slight shift in a fish's scale color completely dictates whether an entire generation lives or dies. It's like an underwater soap opera.
That is a great way to put it, which, forces us to immediately confront the primary conflict the breeder is actually facing here.
Right, the space issue.
Yeah, before we can even analyze the precise moment of separation, we have to understand the fundamental dilemma of keeping them together in the first place.
Right, why not just separate them immediately?
Exactly. If you connect this to the broader science of managing any enclosed ecosystem, it always boils down to resource allocation. And in an aquarium, the absolute most finite, precious resource is spatial volume.
Right. And Ang specifically highlights two species in this log, jewel-cichlids and zebra-cichlids.
Yeah.
And in a perfect infinite world, a breeder would just give every single new generation its own sprawling, separate aquatic estate, right?
That would be the dream.
But the reality of fish keeping is that you are bounded by the glass.
Yeah.
I mean, most breeders do not just have 20 extra tanks running on standby in their garage.
The spatial constraints are just severe. So consequently, Aang documents this very specific, almost counterintuitive strategy.
Which is wild to me.
Right. The strategy is keeping the family unit completely intact.
Yeah.
The breeder intentionally leaves the brooding pair, the parents, and their offspring in the same confined space, even after those fries matured into adults.
Which, I mean, on the surface, that sounds like a terrible idea.
It sounds like a recipe for disaster.
Right, because if space is your primary limiting factor, why would you deliberately cram fully grown offspring into the exact same footprint as the parents? It feels like you're just accelerating a crisis.
It really does. But Aang's notes reveal this is actually a highly calculated move. It's done to manipulate the parent's internal biology.
Okay, well, how does that work?
Well, leaving the tank crowded is a tactical decision designed specifically to prevent the brooding pair from initiating a second spawn.
Oh, wow. So it's like human kids staying in their parents' basement so the parents don't have more kids.
That is actually a perfect analogy. Yes.
Yeah.
It is a brilliant hijacking of their evolutionary programming.
Okay, so the older kids being around stops the parents from having more.
Exactly. The presence of those older fry acts as a biological suppression mechanism. In their natural habitat, initiating a new breeding cycle demands a massive expenditure of metabolic energy from the parents.
Just a lot out of them.
Huge biological investment. So when the tank remains saturated with their own previous offspring, the environmental feedback loop essentially tells the parent's endocrine systems, hey, the territory is at maximum carrying capacity.
Ah, I see. So it's not that the parents are like consciously making a family planning decision.
No, no, not at all.
It is a totally physiological response to overcrowding. So we could look at this like a thermostat feedback loop.
Yes, exactly like a thermostat.
The physical presence of the fry, their movement, the chemical markers they leave in the water, the spatial displacement, all of that acts as the heat in the room.
Right.
And as long as that heat is present, it signals the furnace, which is the parent's reproductive drive, to stay completely shut off.
That is a very precise way to frame it. The sensory inputs of a saturated environment physically suppress the hormonal triggers that are required for reproduction.
Which is just incredibly convenient for the breeder.
It is. For a breeder like Aang, who simply cannot physically house a second batch of fry, artificially maintaining that suppression is really the only viable path forward. The adult fry serve as living placeholders.
Right, occupying the territory.
Exactly, occupying those resources just to keep their parents' drives chemically neutralized.
But, I mean, that suppression only works if the environment remains static, and biology is never static, right? A thermostat can only hold back a furnace for so long before the underlying pressure builds, which brings up a really critical question.
What breaks the equilibrium?
Exactly. If keeping them together works to save space, when does the tension finally boil over? What forces the breeder's hand to step in and evict the fry?
Well, that catalyst is actually the first major factor for separation that Aang details in the log. Because, like you said, that biological suppression is strictly temporary.
Right.
Eventually, the fundamental evolutionary drive to propagate just overrides the environmental feedback.
The furnace turns on anyway.
Yep. The primary indicator that the breeder's window is closing is a drastic, really aggressive shift in the parent's behavior. The biological imperative just punches right through the environmental constraints.
And Aang identifies the exact physical manifestation of this behavioral shift, which is wild. The transition begins the very moment the brooding pair starts preparing for a new spawn.
Yes, and their method of preparation is super specific.
They start meticulously cleaning a flat rock at the bottom of the tank.
Yeah, just scrubbing a rock. And simultaneous to that cleaning, their territoriality skyrockets. They begin actively and aggressively chasing their current fry away from the vicinity of that flat rock.
Let's dissect the neurobiology of this flip, because it is a radical transformation.
It's instantaneous.
These parent fish go from coexisting relatively peacefully with their own offspring to suddenly perceiving them as straight-up enemies. How does the act of cleaning a flat rock trigger such an extreme psychological override?
Well, you have to analyze what that flat rock actually represents to them.
Okay.
In the ecology of a cichlid, cleaning a flat surface is not an act of domestic tidying. That rock is the designated nursery.
Oh, I see.
It is the specific engineered surface where the female fully intends to deposit a new clutch of eggs. So when a breeder observes this meticulous cleaning behavior, it signifies that the parent's internal hormonal state has completely reset.
Wow. So they are essentially terraforming. They're establishing a beachhead for the next generation.
Precisely. And the moment that beachhead is established, the biological categorization of the older fry instantly changes in their brains.
They aren't family anymore.
Exactly.
Yeah.
They are no longer recognized as kin to be tolerated. The parents' brains recategorize those older fry, who, remember, are now large enough to actually consume eggs. They categorize them as apex predators.
Right. They're huge threats now.
Immediate existential threats to the unlaid eggs.
It is such a striking irony. I mean, if you are a casual observer watching an animal carefully clean its habitat, you might think, oh, that's a positive, almost nurturing behavior. Look how tidy they are.
Right, it looks cute.
But in the context of this confined micro-ecosystem, that cleaning is basically the equivalent of arming a warhead.
It's exactly what it is.
It is a localized zone of extreme violence that is just about to erupt. The cleaner that flat rock gets, the closer the tank is to a total bloodbath.
Which means the breeder's ability to read the environment must be absolutely flawless.
Timing is everything.
The moment that rock is deemed clean by the parents and the chasing initiates, the timeline accelerates incredibly rapidly. The breeder must extract the older fry to a separate grow-out tank before the parents escalate their behavior from mere territorial chasing to lethal elimination.
Because in a glass box, the fry can't just swim away to a different part of the river.
Nope, the parents will systematically neutralize the threat.
Man, that is intense. So, parental aggression is the first trigger for separation. You literally watch the rock.
Watch the rock.
But what if the parent's biological thermostat holds? What if they don't override the suppression and they never start terraforming the nursery? The environment is still changing, right? Because the fry are continually consuming resources and growing.
Exactly. If the parents do not force an eviction through behavioral aggression, the sheer physical development of the fry forces a mechanical separation.
So they just get too big.
Yeah, this is the second criteria.
Yeah.
Any documents in the log.
Right, and Ang outlines very specific biometric milestones here. The log says the fry must be separated when they reach between 1 centimeter and 1.5 centimeters in length.
Which is pretty tiny, but significant for them.
Yeah, and reaching this size typically takes about 4 to 6 weeks, so a month to a month and a half post-hatching. However, Ang includes this really vital caveat. This timeline is entirely dependent on the breeder utilizing a technique called aggressive feeding.
Because the caloric intake completely dictates the speed of the biological clock.
Okay, let's clarify the mechanics of aggressive feeding because honestly, it sounds like a highly emotional act, like the breeder is furiously throwing flakes into the water out of anger.
Yeah, it does sound a bit hostile.
But it is actually a very precise metabolic strategy, right?
It is. In aquaculture, feeding aggressively just means intentionally pushing the fry's metabolic rate to its absolute limit. You do this by supplying a very high volume and a very high frequency of food.
Ah, okay.
You are basically maximizing protein synthesis to force rapid, accelerated growth.
So you just want them to grow up as fast as possible.
Exactly. It is about minimizing the time they spend in their most vulnerable, underdeveloped state. If you push their metabolism, they cross that 1 to 1.5 centimeter threshold rapidly, closer to the 4-week mark.
And if you don't?
If the feeding is conservative, the timeline extends and you risk other complications.
But why that specific measurement? Like, why is 1.5 centimeters the critical inflection point? It can't just be an arbitrary number Ang picked out of thin air.
No, it's not.
There has to be a physical or chemical threshold they're crossing at that exact size that destabilizes the tank.
You're right. There are actually a few intersecting factors at that size. First, there's the sheer bioload.
Right, the waste.
Yeah. A tank full of 1.5 centimeter fish produces exponentially more waste and consumes significantly more oxygen than a tank of newly hatched fry. The chemical stability of the water begins to degrade really rapidly at that point.
That makes sense.
And second, their mobility and spatial displacement at that size means they're just occupying way too much of the physical water column.
They're bumping into everyone.
Exactly. It drastically increases stress on all the inhabitants.
Which brings up a very practical problem for the breeder. I mean, you cannot exactly hold a ruler up to the glass and accurately measure a chaotic swarm of moving fish to see if they've hit exactly 1.5 centimeters.
No, it's logistically impossible. They don't hold still.
Right. So how do you know?
Well, this is why the visual markers of biological maturity are the true indicators. Reaching that size correlates with a massive physiological shift.
Oh, like puberty.
Is essentially, yes, aquatic puberty.
And Ang's log details exactly what this looks like for both species we mentioned. For the juvenile jewel-cichlids, this maturity is signaled by the sudden development of vibrant red or pink coloration.
Very distinct colors.
And then for the zebra-cichlids, it is the emergence of these stark vertical stripes. Now, on one hand, this seems incredibly convenient for the breeder. Nature provides a literal color-coded warning system.
Yeah, it's like a built-in alarm.
The fish physically change color to announce, hey, we're mature, time to move us. But if we think about this evolutionarily, inside the confines of a glass tank, developing these bright colors seems like a massive biological liability.
Oh, it is a profound liability in captivity.
Right.
In their natural expansive habitat, shedding their juvenile camouflage and developing these vibrant colors or stripes serves crucial evolutionary purposes.
Like finding mates.
Exactly. It might be for attracting mates, establishing social hierarchies, or even blending into complex reef or riverbed environments depending on the species. It is a fundamental biological assertion of adulthood.
But in a 40-gallon breeder tank, asserting your adulthood by suddenly turning bright pink is basically painting a massive target on your own back.
It really is.
The moment those colors emerge, they are no longer visually camouflaged as harmless babies to their parents.
Wow.
They are visually broadcasting themselves as mature competitors for resources. It's this wild situation where an evolutionary adaptation is fundamentally clashing with the artificial constraints of the aquarium.
And that is the exact tension the breeder is managing. The color shift is the undeniable visual confirmation that the initial strategy, using the fry to suppress the parent's breeding drive, has reached its absolute physical and biological limit.
The jig is up.
Exactly. The fry are now independent juveniles. They're capable of surviving in a grow-out tank, and their continued presence will inevitably trigger the parent's territorial aggression. They absolutely must be moved.
Right. So up to this point in Eng's log, the methodology is highly structured. You manage the spatial constraints. You monitor the flat rock for signs of behavioral shifting.
Yep.
If the rock remains untouched, you monitor the fry for the emergence of red scales or vertical stripes, and then you execute the separation. It is a very logical, observable system.
It is a system, but it's predicated entirely on the assumption that biological drives will follow a predictable sequence.
Which brings us to the dark part of the log. Because biological systems under artificial pressure do not always behave predictably. And the final section of Eng's notes addresses a catastrophic failure of this system. It details a really grim, brutal exception to all these neat, orderly rules.
It really highlights the stark reality of manipulating living organisms. Despite meticulous observation and perfect environmental management, the equilibrium can just shatter.
Yeah.
Eng documents scenarios where the suppression strategy fails so violently that one of the brooding pair is actually killed.
It's shocking. Eng notes that while the exact trigger can be a bit ambiguous, the casualty is almost exclusively the female.
Yes.
And the working hypothesis in the log is that her death is the direct result of the male's overwhelming, uncontrollable aggression to initiate a new spawn.
This is where we witness the genuinely lethal consequences of confining ancient instincts within glass walls. We really have to examine the physiological mismatch occurring here.
What's happening in his brain?
Well, the male's internal drive to reproduce becomes so highly pressurized that it absolutely demands an outlet. However, the environmental conditions are actively blocking that outlet.
Right, the older fry might still be occupying the territory.
Exactly. Or the female simply may not be physiologically ready to produce a new clutch of eggs yet.
So his evolutionary imperative to breed essentially short circuits.
That's a good way to describe it.
And because the tank is a closed system, the female has zero avenues for escape. In a river, she would simply swim away from an overly aggressive mate until she was ready, right?
Exactly. She'd just leave the area. But the artificial boundary of the aquarium turns a natural biological drive into a localized, inescapable weapon. His aggression, which is born entirely out of this thwarted instinct to create life, ultimately destroys his reproductive partner.
It's tragic.
It is. He fundamentally and permanently alters the ecosystem of the tank.
Which leads to an incredibly bizarre shift in the management of the tank. I mean, you would assume that if a male has just exhibited lethal aggression, the absolute first priority would be to evacuate the remaining fry before he turns on them too.
You would think so, yeah.
But Eng's notes suggest the exact opposite. In this specific tragic scenario, the surviving male is actually left in the tank to live with the fry.
Yeah, because the biological equation of the tank has been fundamentally rewritten. By killing the female, the male has permanently eliminated the possibility of a new spawn. The eggs he was aggressively trying to secure a territory for will never exist.
So his hormonal drive just crashes.
Exactly.
The very thing causing his rage, the biological push to secure a nursery for a new generation, is completely neutralized by the absence of a mate.
Precisely. Without the potential for new offspring, his perception of the older fry shifts yet again. They are no longer threats to future eggs simply because there are no future eggs. Eng observes that his role in the microecosystem devolves from a hyper-aggressive territorial mate to something entirely utilitarian. He basically becomes the tank's janitor.
Wait, really? A janitor?
Yeah. He exists solely to scavenge unfinished food pellets and maintain a baseline level of biological order among the fry.
That is a staggering reversion of his biological purpose. I mean, we began this deep dive talking about the serene, calming aesthetic of an aquarium, but the reality for this surviving male is incredibly grim.
It's a dark reality.
His unchecked evolutionary rage results in the loss of his partner, and the direct consequence is that his complex reproductive life is just over. He is doomed to live out his days in a confined space with his maturing teenagers, just scavenging their leftover food.
It is a brutal outcome, absolutely.
Sure.
But from a purely ecological standpoint, it represents a new, unshakable equilibrium.
The tank stabilizes.
Yes, the volatile variable, the drive to reproduce, has been forcibly excised from the environment. The tank stabilizes, allowing the male and his fry to coexist without the looming threat of territorial violence.
It is a dark stability, but a stability nonetheless. It completely reorients how you look at the dynamics inside that glass box.
Definitely changes the perspective.
So to sort of synthesize this for you, the listener, what Ang's log reveals is the extraordinary complexity hidden beneath the surface of fish keeping.
Right.
Managing a breeding tank is definitely not a passive hobby.
Not at all.
It is an active negotiation with raw biology. You are constantly balancing severe spatial limitations against the chemical and visual feedback loops of the fish. You are analyzing the terraforming of a flat rock as an indicator of impending violence.
You're reading the tea leaves.
Exactly. You are tracking the metabolic growth of the fry, waiting for an evolutionary color shift to force separation. And then you are forced to reckon with the lethal consequences when natural instincts violently collide with artificial constraints.
It really demonstrates that managing a microecosystem is fundamentally about understanding causality.
Right.
Every physical change in the environment triggers a biological response, and every biological response places a new pressure on the environment. Recognizing those interconnected loops is completely essential, whether you are managing a 40-gallon tank or a massive open-air habitat.
It all comes down to the friction between the environment and the instinct. And, that leaves me with a lingering thought for you to consider as we close out today's deep dive.
What's that?
Well, we just broke down how a male cichlid's unstoppable biological programming to reproduce ultimately resulted in the death of his mate, simply because they were confined to a space that didn't allow for a natural retreat.
Right.
The artificial boundary turned an instinct into a fatality. It makes you wonder, if we look beyond the aquarium, how often in our own complex, highly structured human environments do our own artificial boundaries, like our societal rules, our physical spaces, our economic constraints, tragically and invisibly clash with our deepest, oldest biological instincts?
Wow. That is a critical lens through which to view not just ecology, but our own behavioral systems.
It is definitely something to keep turning over in your mind. Thank you for joining us for this deep dive, and we will be back next time to deconstruct another complex piece of the world around us.